Today we're going to review the transport of lipids by serum lipoproteins. Lipoproteins have a core of hydrophobic lipids, usually triglycerides and cholesterol, and they have a shell of polar lipids, cholesterol and phospholipids, and proteins that both hold the structure together and also provide tags that allow this particle to interact with receptors and enzymes. We're going to talk about four different lipoproteins: chylomicrons, which transport dietary lipids from the gut; very low density lipoproteins that transport lipids from the liver; and low and high density lipoproteins, which are important in cholesterol transport. The liver takes up dietary lipids and makes chylomicrons. These are very rich in triglycerides. They also contain dietary cholesterol and biliary cholesterol. As these particles circulate through the capillaries, they encounter lipoprotein lipase, which hydrolyzes the triglycerides and releases free fatty acids. Lipoprotein lipase is in adipose tissue and muscle. The fatty acids are used in muscle as fuel, and in adipose tissue, the fatty acids are incorporated into triglycerides. The chylomicron remnants, which have the dietary and biliary cholesterol, are taken up by the liver and broken down, adding the cholesterol to the liver's cholesterol pool. The liver makes VLDL. VLDL is a triglyceride-rich particle. It contains fatty acids that are made de novo from the liver, and it also contains fatty acids that are being recycled on their way back to adipose tissue. As the VLDL particles circulate, they also encounter lipoprotein lipase in adipose tissue and muscle. The triacylglycerols are broken down, and as a consequence, those triglycerides are lost and taken up by these tissues. The VLDL particles become more dense, they turn into IDL, and they then pick up cholesterol in a process that I'll talk about in just a second, and turn into low-density lipoprotein. These are cholesterol and cholesterol ester-rich particles. These molecules can then be cleared from the circulation by low-density lipoprotein receptors, and that process occurs both in liver and in extrahepatic tissue. We also need to talk about HDL, high-density lipoproteins, because they play an extremely important role in cholesterol homeostasis. The most important lipoprotein in HDL is ApoA1. ApoA1 is made in liver and other tissues, and as it circulates, it collects free cholesterol, FC, and it does it from non-hepatic tissues with the help of a transporter, ABCA1. Most tissues have the ability to make cholesterol, but they do not have the ability to break it down, and so in order to maintain cholesterol balance, they need to pass off their cholesterol to HDL with the help of ABCA1. As the HDL circulates, it interacts with an enzyme called LCAT, which changes the cholesterol into cholesterol esters, that's the CE, taking a fatty acid chain from an existing phospholipid, and the enzyme adds that to cholesterol to make cholesterol esters. As the cholesterol-rich HDL particles circulate, they can do one of two things. They can transfer that cholesterol directly to the liver through scavenger receptor B1, SRB1. So this process takes cholesterol from non-hepatic tissues, it transfers it to the liver in a process called reverse cholesterol transport. The liver has the ability to turn cholesterol into bile acids and carry out the net turnover of cholesterol. And so this process of net cholesterol transport, reverse cholesterol transport, takes cholesterol from non-hepatic tissues, takes it to the liver where it can be turned over. HDL can also exchange lipids with intermediate and low-density lipoproteins. There are exchange proteins that do it. Phospholipids can be exchanged using a phospholipid transfer protein, and cholesterol esters can be exchanged. And this process aids the maturation of VLDL, triglyceride-rich, into IDL, which has lost some of its triglycerides and gained cholesterol, and LDL, which is even more cholesterol-rich. And that cholesterol can then transfer its cholesterol either to the liver or to extrahepatic tissues. We have to worry about the level of cholesterol in these two lipoproteins because they are risk factors for coronary artery disease. High levels of HDL are protective. So high levels of HDL will protect a patient from coronary artery disease, and the reason for that has to do with reverse cholesterol transport. High levels of HDL will take cholesterol from non-hepatic tissues and get it to the liver where it can be broken down. In contrast, low levels of LDL are a risk factor for coronary artery disease. So going in this direction, high levels of LDL are a risk factor for coronary artery disease, and the reason for that is shown on the next slide. What happens when cells take up cholesterol from LDL is that the cell becomes rich in cholesterol, and a signaling mechanism turns down new cholesterol synthesis, but it also turns down the level of LDL receptors. So a cell that's full of cholesterol will stop taking up LDL because it doesn't have the necessary receptor. What happens then is that the LDL in the circulation is subject to damage. Its lifetime in the circulation is prolonged, and it can be oxidized in a number of different processes. This oxidized LDL is no longer a substrate for the LDL receptor, but is a substrate for scavenger receptors. And a prime place for these scavenger receptors are macrophages. Macrophages, of course, are pro-inflammatory cells, and when these cells take up the oxidized LDL, the cholesterol gets deposited in lipid droplets. These cells can't metabolize cholesterol, and the stored lipid, it appears in these lipid droplets that makes the cells look foamy, and these cells are therefore called foam cells. Macrophages are pro-inflammatory cells, and a macrophage that's been turned into a foam cell is busy releasing all kinds of inflammatory and chemotactic factors that in artery walls will initiate the process of atherosclerosis. The dying foam cells will form lipid-rich lesions, atherosclerotic lesions, and in addition, the chemotactic factors will attract more inflammatory cells, will cause smooth muscle changes, and the result is an atherosclerotic lesion. And there are two kinds of risk. One is the occlusion of circulation can simply cause ischemia because of lack of circulation. And in addition, the atherosclerotic lesion can nucleate thrombosis, and the result is an acute infarct. So for these reasons, we have to care a lot about LDL and HDL, and in addition, interventions to regulate the levels of these lipids in the circulation is extremely important in mitigating the risk for coronary artery disease.